Okay, finishing your previous section on finding the foot of a perpendicular from a point down to a line or a point down to a plane, and thereafter we use it to find the reflection of a point in a line or a point in a plane. We will now move on to the next section, which is finding distances. So when it comes to finding distances, in a nutshell, there's actually three methods. Okay, the first method is actually an extension of your previous section. If you actually have found a foot of perpendicular from a point down to a line or a point down to a plane, you can actually find the magnitude, and that will be the shortest distance from your point down to your line or your plane. That's your method 1. Alternatively, if you can recall your chapter 2 and chapter 3, you can find distances using the projection method or the cross product method. Okay, so that will be your method 2 and method 3 respectively. So in a nutshell, which method to choose, method 1, 2 or 3, depends on available information and also depends on how the question is being set. Okay, so just a quick revision. Okay, these are the two items that you actually learned or went through quite a lot in your chapter 2 and chapter 3. Okay, h dot a hat is the length of projection formula. H cross a hat is the distance of the side perpendicular to your known vector. That is in your chapter 2 and chapter 3. And for those who actually have forgotten, this was the diagram that I'm trying to tell you. Okay, h dot a hat. In the context of this question, this is h dot a hat. You actually get CP, which is the length of projection. H cross a hat, you actually get the length HP. Okay, so these are the two things that you actually have learned earlier on. So now, in the context of a point to a line, so diagrammatically, what I'm trying to find is this distance. Okay, the shortest distance from a point down to a line. So if you were to continue from your previous example 5, okay, you have point A and you have a line L. Your job is to find the distance from A to L. So if I were to draw, okay, what actually is happening? This is my point A, this is my line L. Okay, the shortest distance, if I were to use method 1, would be actually the length of AF, where F is the foot of perpendicular that you have found previously. So if OF is equals to this vector, OA is equals to this vector, you can find AF using OF minus OA, and thereafter find the magnitude of this minus 1, 2, minus 2, and that will be the length of your distance from point A to the line L. Alternatively, if you actually want to bypass, means I don't even want to find the foot of perpendicular first, can you actually find the length of AF? Okay, so you can do this via your dot product, okay, or your length of projection formula. So analyze what actually do you have. You have the point A, you have the line L, okay, and in the line L you have a point. Okay, I'm going to call this point C. Okay, I'm going to call this point C. And what is the position vector of C? Position vector of C will be 8, 0, minus 1. So actually I can find CA. Go and dot with the direction vector of the line L, which is minus 614 divided by its magnitude, and that I will get the length of projection, which is CF. Okay, so these directly will give me the length of CF, which is the length of projection of CA onto the line L. I get this length, but I'm interested in the length of AF. So what do? I actually activate Pythagoras theorem. So using Pythagoras theorem, I can also find the length of AF. Alternatively, I can actually go through everything very quickly. So again, I have the point C, I have the point A. So instead of using dot product, I activate my cross product formula. So CA with your U hat will give me the length of AF immediately. Okay, CA cross with U hat will give me the length of AF immediately, and if I just work out a value, it will be exactly the same. So I have gone through 3 different methods, okay, to find the shortest distance from a point down to a line. Again, okay, I emphasize again, which method do you actually activate during the actual exam or during the questions depends on how the question is being set, and depends on your form that day. Which one can you actually remember? Okay, so now let's do some extension. How about instead of pointing to a line, can you actually find for me distances between 2 parallel lines? So at this point, I want to emphasize, if the 2 lines are not parallel, the line will 100% wrong. If the lines are not parallel, there's a chance that the lines totally don't intersect, or there's a chance that the line will 100% intersect. So as far as your syllabus is concerned, please remember, if I were to ask you to find distance between 2 parallel lines, the lines 100% must be parallel. I say again, for your syllabus, if I ask for the distance between 2 lines, the lines must be parallel. So if I were to fall back again onto this diagram, I have 2 lines. I ask for the distance between the 2 lines. It will be the length of BF. Okay, so let's understand. I have a point A, it's down here on line L1. I have a point B on L2. Can I actually go and find vector AB? And then I have the direction vector of my line L1, which is U. I have the direction vector of the line L2, which is V. And U and V are parallel. So if you look at this diagram again, if I'm interested in my BF, okay, the length of BF here, I can actually activate method 2 or method 3 very quickly. Okay, so let's talk method 3 immediately. If AB cross with U hat, I will get my length of BF very quickly. So which is this formula that I'm activating, which is your method 3. Okay, can I use method 2? Of course you can, just that it's a little bit more tedious. So one example to run you through: find the shortest distance between the 2 lines given. So line 1, line 2, observe, they are parallel. Okay, so next what you need to do is to try and visualize what's happening. So you actually try and draw. Okay, so when you try and draw, so fit in where is this point, fit in where is this point. So in the diagram, okay, given to you, I fit in point A to be here, I fit in point B to be here. So can I go and find vector AB? So vector AB is found by OB minus OA. Next, which is the direction vector that you're supposed to be using? I can use either V or U. It doesn't really matter. Okay, so I can actually go and find U hat. And if I can actually activate this formula again, your cross product formula, I can get the distance between the 2 lines very, very quickly. Moving on to the next part, instead of doing point and line and line and line, we now proceed on to shortest distance between a point and a plane. So one example to run you through is same thing. I can use method 1 or other methods. So let's run through method 1 first. Method 1 is actually I find the foot of perpendicular from a point down to a plane first, which actually we covered in your 6.2. So if I have 1 point and I have the equation down here, can I actually find the foot of perpendicular? I find it using your example 7 earlier on. And once I have the foot of perpendicular, I can find PF. Okay, vector PF, and hence thereafter the magnitude of PF. So this will be your method 1 method, which is very, very fast. Alternatively, I can use method 2 which is your projection method. So what I want you to understand are a few things. Okay, number one, okay, let me just push down the diagram, it's a bit off. Okay, so what I have down here, example 10. Okay, now the diagram is correct. Okay, what you have down here is I have a point P given. Your job is to find the shortest distance from a point P down to a plane. So what you need to know is, you need to know what you have. So you draw point P first, followed by a plane. Okay, right, this is the normal vector of the plane. Next, okay, I need to generate this triangle so that you can actually activate certain of your formulas. So I need a point on the plane. So where does the point come from? I need to go back to the equation of the line. Equation on the plane. This is the equation of the plane. Any point that can satisfy this equation will be a point that lies on this plane. So can I say 2, 0, 0? Okay, let OA be 2, 0, 0. 2, 0, 0 will satisfy this equation. Just test. 2, 0, 1. I actually get 4, which is the right hand side of the equation. So 2, 0, 0 is a point on the plane. If I don't like 2, 0, 0, can I use 0, 0, 4? Okay, 0, 0, 4 will give me 4. So 0, 0, 4 is also a point on the plane. So your job here is to actually so-called find a point on the plane. And a point that will be easier for calculation will be a point with as many zeros as possible. So for lecture purposes, I'm going to let point A be 2, 0, 0. Okay, I let point A be 2, 0, 0. So if I have point A 2, 0, 0, I can find what is vector PA using OA minus OP. Next, analyze what do you have. In the equation of the plane, I don't have direction vector. I have a normal vector. Okay, I have a normal vector. So actually I have this thing. Okay, I have this thing. So whether your arrow is up or arrow is down, the choice is yours. Not really important right now. So what I have is PA. And I have the normal vector. So PA dot with my normal vectors followed by divided by its magnitude. This one is actually your length of projection. PA dot with this direction, actually I get PF. Okay, PA dot with n hat, I get PF. This is your length of projection, and this length of projection is actually the distance of point P down to your plane. Okay, this one is your distance of your point P down to the plane. So there is no method 3 for this shortest distance from point to a plane, unlike your previous distance from a point down to a line. So next, if I were to say I want you to find the shortest distance between the origin and the plane, it isn't anything fantastic. So instead of considering the point P right on top, I'm going to consider origin right on top. Okay, the procedure is the same. Can you give me a point on the plane? Remember, a point on the plane will be any value that can satisfy the equation of the plane. And again, if I were to activate my projection formula, it will be OA dot n hat. OA dot n hat, it is actually, to simplify, you actually get this simplistic equation, okay, which is actually r dot n. This is your equation on the plane. All you need to do is to divide the p value by the magnitude of the normal vector. Okay, it's a little bit confusing right now, so let me run through with an example and everything becomes very, very clear. Okay, so r dot n, r dot 201 equals to 4. This is in the form of r dot n is equals to p. Okay, your job is to find the shortest distance from the origin to the plane pi. So of course you can actually go through the whole process, okay, guess a point on the plane and proceed. But if you just want to pull out the formula, the distance between the origin and the plane is just p value, okay, the p value here divided by the magnitude of n. Okay, so activating the formula, it is just 4 p value divided by magnitude of n. And this was the shortest distance of a plane, shortest distance from origin down to a plane. Okay, if you don't really want this, okay, there is nothing stopping you to actually fall back onto your same old method here. Change your p value, p coordinate to 0, 0, 0, and everything will still work. Okay, so why actually do we want to mention something like this? Is because there was 1 year in the A levels by which actually they asked the students what's the meaning of magnitude of p over n. So you need to know is the distance of origin down to the plane. Okay, the next part will be distance between two parallel planes. So now this is, before we touch on this, please understand a few things. Will two planes that are not parallel always intersect? Okay, the answer is yes. If the two planes are not parallel, they will surely intersect somewhere. So if I ask you to find the distance between two planes, again, just like your lines, the planes must be parallel. Okay, so the theory is again very simple. You can actually use the same theory all over again, okay, which is this one, finding the shortest distance from a point down to a plane. So all you need to do is, okay, remember finding a point down the plane, identify a point on one plane, and then find the shortest distance from this point down. It will be exactly the same, okay, and then actually give you the distance from one point or the distance between two planes. So one example to run you through, okay, your job is to find the distance between pi 1 and pi 2. So make some observation. The normal vector are parallel. So what it means is that the two planes are parallel. Okay, so what I'm going to do now is I'm going to find 2 points that is on pi 1 and pi 2 respectively. Okay, I need to find 2 points that are on pi 1 and pi 2 respectively. So the trick is find points with as many zeros as possible that can satisfy the equation. So looking at this first equation, I'm going to get 0, 0, 27. Okay, 0, 0, 27 will satisfy the equation on the first plane. So I let this point be 8. Next, I'm going to get 0, 0, negative 4.5 to be on this plane because it has many zeros and it satisfies the equation. So I have point A, point B that lies on pi 1 and pi 2 respectively. So this is what I have. I got point A, I got point B. Your job is to find for me the distance between two planes, which is BF. So I can actually find AB. Since I have OA, I have OB. Next, this is my normal vector. Then if I were to do a projection of AB on N, I actually get the length BF. Okay, AB dot with N hat will give me my length BF, and that will be the length of projection, which is actually the distance between the two planes. The last bit that we have, okay, will be the distance between a plane and a line. Okay, so some important concept. Okay, if a line does not intersect the plane, the line is 100% parallel to the plane. Okay, so how then can you find something like this?